Algebra 2, Chapter 2.3, exercises 1 through 13. We're going to, in this set, solve absolute value inequalities, and particularly I'm going to work on the odd number ones here. One, determine whether each of the integers from -5 to 5 is a solution of the inequality, the absolute value of quantity x minus 1 plus 3 is greater than or equal to 5. And if the number is a solution, plot it on the number line. So if we set, basically what we can do here is we'll do a little algebra in subtracting 3 from both sides of this inequality. So we're looking for integer values that are going to make quantity absolute value of x minus 1 greater than or equal to 2. And we're going to try these one at a time. So if we plug in -5, so if we get -5 minus 1, that's going to be -6, but that -6 is going to be positive, which is greater than or equal to 2. So -5 is a solution. -4, if we take -4 minus 1, well, that's going to end up being -5, which will be greater than or equal to 2. That is a solution. If we take -3 minus 1 is -4, and -4 becomes +4, which is greater than or equal to 2. If we plug in -2 minus 1, well, that's -3, that becomes positive, which is greater than or equal to 2. And then if we plug in -1, well, -1 minus 1, that's going to be -2, but that's going to be +2, which is not greater than, but equal to, so -1 would also qualify. And so that becomes a boundary point. So if we take 0, well, 0 minus 1 is going to be -1, and -1 is not greater than or equal to 2, so that one is not a solution. If we plug in 1 minus 1 is 0. 2 minus 1, we'll end up getting 1. Now if we take 3, minus 1 is 2, and 2, absolute value of 2 is greater than or equal to. If we plug in 3, we get a solution. And if we plug in 4, okay, 4 minus 1 is 3. Absolute value of 3 is greater than or equal to 2. And finally 5. 5 minus 1 is 4. Absolute value of 4 is greater than or equal to 2. So here we have all the solutions graphed on our number line, and if we put those solutions in set notation, we would write them as -5, comma -4, comma -3, comma -2. Comma -1, comma 3, comma 4, comma 5. Set notation. And we could say x equals. There we go. Let's go to the next odd number problem, which is 3. Solve each inequality graphically. What we have is we have two sides of an inequality. The left side is 2 times absolute value of x, and that parent function has the vertex at the origin and has, we go up 2 over 1, so we're going to be looking like something like this. So here would be a graph of that. Okay, there we go. All right, so more or less, that's it. And then the other side we're going to be coming down here. I can make it a little bit better. That's a little bit better. And then we'll be coming from here, here, here. So there it is. We can verify with our graphing calculator is less than or equal to 6. So graph y equals 6, and here it is. Y equals 6. Scores all aligned at y equals 6. So y is equal to 6. And we want to know where the value of this expression, 2 times absolute value of x, is less than or equal to. Well, it's going to happen right here between x equals -3. And in fact, what I'm going to do here is I'm just going to put the coordinate pair here. I'll put -3, comma 6, and on the other side we're going to have 3, comma 6. So remember, I don't know if you remember, I said the chant, more is or, less is nest. And so we are right in between. And so x is going to be greater than or equal to -3 and less than or equal to 3. And we could see that if we tried numbers. We put in 0. Would that be right? Yeah, if we plugged in -3, 2 times that's the value of -3 is less than. If we went less than -3, wouldn't work anymore. So this is going to be our solution to this inequality. We solve it graphically and describe it below an inequality notation. And you could also put that in interval notation. All right. Okay, next on our problem. 5. We have 1/2 absolute value of x plus 2 is less than 3. Well, the first thing I'm going to do is solve this or get rid of that. Well, no, I'm going to just graph the left side as given. We have, if we take y equals 1/2 x plus 2, well, our vertex for that is going to be the point 0, comma 2. So here we go. There's our vertex. And our a value is 1/2. So we go up 1 over 2. Up 1 over 2. So we're going to be looking like this on this side. And yes, a little inaccurately drawn. And on the other side, we're going to be looking like this. Up 1 over 2. So let's put that in place here. So a little bit off looking, but that'll be close enough. We can kind of see. That's not right. What it is, we're going like this. Yeah, it's going to go like this. Like this, so it's going to come like this. There, it looks better now. Okay, it's less than 3. And so we're going to put 3 right here. So that's going to be y is equal to 3. So we have this one here. And where do we see less than? Well, our boundary points here are going to be -2 and +2. So I'll put the points here, -2, comma 3. And then on the other side, we're going to put 2, comma 3. And we have less than, so our solution is going to be x is greater than, x equals -2, but less than x equals 2. And in interval notation, we will say, oops, we have open parentheses, -2, comma 2. So we have here above in inequality notation, below in interval notation, our solutions. Next, match each graph with its corresponding absolute value inequality, then give the solution of the inequality. And so I'm going to try just to do numbers 7 and 9, but in reality, you'd be able to do all of these. This one, 7, we have our vertex here, so that at -1. So for this one here, 7, k is equal to -1. And where do we see a k being equal to -1? We see it right here. So my suspicions are that this would be C, if we have the two absolute values. So we have up to over 1, right? So that's true, up to over 1. So that checks out. Up to over 1. So that's where it is. So we will say, we'll call graph 7, we'll call that C. And it says, then give the solution of the inequality. Well, that's going to be greater than 3. So that's going to be above. So this is going to be a more is or. So we have, I'm going to bring this down here, not a whole lot of them. No, I'll bring it over to the right. So you have 2 absolute value of x minus 1 is greater than 3. And it looks like we should be between less than -2, right? And greater than 2. So I'll say x is less than -2. More is or, right? Or x is greater than 2. And algebraically, if we solve this, 1 add 1, so it says, doesn't say which way to solve, so we get 2 times absolute value of x is greater than 4. And we divide by 2, we get absolute value of x is greater than 2. So it means x is greater than 2, and then when we have to switch the direction of the inequality if we make this -2, and so x is also going to be less than -2, and that'll be or. So that's number 7. 9, it looks like we have our vertex at the point, we have k is -1, so we have -1, comma 0, because k is 0, but h is -1. So what we're going to get for that is +1 inside the bracket here, which is going to be b, and it's a less, so that's going to be b, and this is going to be less than, so less is nest, which means we're going to be between, looks like, negative 2.5 to 0.5. So we would say x is greater than negative 2.5, but less than 0.5, 0.5. Does that look right? Yeah, it looks right. And algebraically, how do we do that? Well, 2 times quantity x plus 1 is less than 3. And if we divide by 2, we get absolute value of x plus 1 is less than 3/2. And then if we take this out to make 2 equations out of it, I'm going to make some room here. We have x plus 1 is less than 3/2, and x plus 1 is greater than negative 3/2. And if we solve here, we subtract 1, we're going to get x is less than 0.5. And if the other one we subtract 1, we're going to get x is greater than negative 2.5, which matches what we've seen here. Next, other problem we're going to look at is 11. Solve each absolute value inequality algebraically, graph the solution on a number line. And so we have this 2 times absolute value quantity x minus 7/2 plus 3 is greater than 4. And so let's go ahead and solve this first. Minus 3, minus 3. So we get 2 times the absolute value of quantity x minus 7/2. And that's going to be greater than 1. And so we have greater than, that's a more is or. If I see your papers with more is or less is nest, I don't know what you're talking about. So the next thing we're going to do to solve this is divide by 2. So we get the absolute value of quantity x minus 7/2 is greater than 1/2. And that's going to go in 2 directions. We're going to have x minus 7/2 is greater than 1/2. And then we're going to have, we take the negative version, we're going to have x minus 7/2 is less than negative 1/2. And that's recalling that we have to switch the direction of the inequality symbol when we divide or multiply by a negative number. So we make this a negative 1/2. We switch the direction of the inequality symbol. And now we add 7/2 to both sides of this first inequality on the left, and we get x is greater than 1/2 plus 7/2, or 8/2, which simplifies to x is greater than 4. And we know that's greater than, so we can come up to the 4 and just put this right here. Okay? Next, let's go ahead and solve this one by adding 7/2 to both sides. So we get x is less than negative 1/2 plus 7/2, which is going to be 6/2. And that simplifies to x is less than 3. So here we put 3. So we have greater than 4. And less than 3. And so we're going to see pretty much everything on the number line except between 3 and 4. We could, if we want to, just take like 3.5 would be the only thing that wouldn't qualify. So if we take 3.5, that would be 7 halves, right? So we get 7 halves minus 7 halves is 0, 2 times 0. 3 would not be greater than 4, so that would not qualify. If we tried every other point greater than 4 or less than 3, we would have our part of the solution set. Okay, we have here, we'll do 13 as the last one in this set. Again, we have a greater than or equal to, but let's go ahead and solve this first by subtracting 2 from each side. So we get 3 times absolute value of quantity x plus 4 is greater than or equal to 5 minus 2, which is 3. And if we divide both sides of this inequality by 3, we get absolute value of quantity x plus 4 is greater than or equal to 1. And now we have two separate cases. We have x plus 4 is greater than or equal to 1, and we have x plus 4 is less than or equal to negative 1. Okay, so let's go ahead and solve this. If we subtract 4, we have x is greater than or equal to negative 3. And then on the other one, if we subtract 4, we have x is less than or equal to negative 5. And so here's our negative 3. And we are greater than or equal to negative 3, so we're going in this direction. And we're here at negative 5. We are less than or equal to negative 5. So we have that. And now we can kind of test points in there. Obviously, negative 4 would not qualify, right? Because everything else really should. All the other integers should. We can try 0 should qualify. If we plug in 0 for x, we'd have 3 times 4. That would check out. If we plug in 4, we'd get negative 4 plus 4 is 0. And 0 plus 2 is not greater than or equal to 5. So those would be our solutions. And that's it for this exercise set. I remind the viewer, again, when doing absolute value inequalities, more is or, less is nest. Okay, that's it. Good luck, and thanks for viewing.